Let's get started with the process of setting up an Amazon Aurora database. Just a heads up, if you choose to follow along with this practical demonstration, keep in mind that it may incur some charges. The key takeaway here is to focus on the instructions and familiarize yourself with the various options available. There's no need to create the database yourself if you're hesitant about any associated costs. We'll begin by selecting the standard Create option. As you explore the Aurora offerings, you'll notice that there are two main choices available. One is MySQL compatible and the other is Postgres compatible. For today's demonstration, I'll opt for the MySQL variant. Next, let's scroll down to the version selection area. Here, you'll find a version selector. For this tutorial, I'll stick with the default version recommended by the Aurora console, which is 3.05.2. However, this may vary depending on your account settings or updates from Amazon. Moving forward, it's time to select a template for our database configuration. Opting for the production template will allow us to have comprehensive control over all the settings, which is precisely what we want, especially when aiming for an optimized database environment. So, let's go ahead and select the production template. For the database cluster identifier within Amazon RDS, I will name it Database 1. Our master username will be set as admin. Next, you'll need to enter a password. I'll do that now to ensure we have secure access to our database. When it comes to cluster storage configuration, you're presented with two choices, Aurora Standard or I/O Optimized. If your operations involve a high volume of input and output, such as numerous read and write transactions, you might find the I/O optimized option suitable for your needs. Conversely, if you're looking for a more economical solution for workloads that don't heavily utilize Aurora, the Aurora Standard option would be a wise choice. Now, let's discuss instance configuration. Here, you have the flexibility to select the instance class that best fits your database requirements. You'll observe various options available, including memory-optimized instances, burstable classes, and whether to incorporate previous generation classes, which can sometimes offer cost savings without significantly affecting performance. For our current purposes, I'll choose the DB instance class. In this section, if you're working with a version that supports serverless configurations, you'll notice the option for Serverless v2 appears here. Unlike traditional instances, you won't be selecting a specific instance type. Instead, you'll choose an Aurora Capacity Unit, or ACU. You'll specify a minimum and maximum ACU, allowing your database to dynamically scale within these parameters. This flexibility is especially useful for applications with fluctuating workloads. For demonstration purposes, I'll opt for the burstable class, specifically db.t3.medium. Moving on to considerations for availability and durability, we have the option to implement Aurora replicas. By creating an Aurora replica and designating a reader node in a different availability zone, AWS, we enhance availability and improve read performance across AWSs, contributing to faster failover capabilities. While this setup may incur higher costs, it truly showcases the robust features of Aurora. Next, we're focusing on compute resources. Instead of connecting to an EC2 instance, we will select IPv4 as our network type, which is sufficient for our current needs. If your virtual private cloud, VPC, supports it, you also have the option to enable dual stack mode if you're utilizing IPv6. You'll be placed within the default VPC, which comes with the pre-configured default subnet group. For accessibility, I recommend allowing public access so that our Aurora database can be accessed via a public IP. In terms of VPC security, I will create a new security group named Demo Database Aurora, which will facilitate connections to our Aurora database effectively. Now, let's delve into additional configurations. The database operates on the standard port 3306, which is used for MySQL connections, assuming you selected MySQL earlier. We also have the capability of enabling local write forwarding. This feature ensures that if any writes are directed to the read replica, they will automatically be forwarded to the primary write instance. This streamlines connection management, making it easier to handle your database resources efficiently. Moreover, we have options for database authentication. You can opt for IAM-based database authentication or leverage Kerberos-based methods, both designed to authenticate users through external mechanisms. Enhanced monitoring features are available, although for our current setup, I can skip this option as it's not crucial at the moment. Lastly, there are several additional settings we can customize for your database to better suit your operational requirements. For instance, let's name our initial database MyDB, and we'll set the backup retention period to 1 day. This is an excellent choice because it ensures you have recent backups available. Furthermore, we have the option to implement encryption for our database, which adds an extra layer of security and protection for sensitive information. Additionally, there are various strategies available for backtracking, which allow us to revert changes in the database if necessary. While I won't delve into specifics here, it's good to know that options such as log exports exist for advanced data management. To prevent accidental deletions, we also have deletion protection, which is crucial for safeguarding your database. Everything appears to be configured correctly at this point. It's important to note, however, that setting up this Aurora database will incur some monthly costs, so always keep that in mind when making your decision. Now, let's proceed with the creation of this database. I'm happy to report that my Aurora database has been successfully created. We can observe a regional cluster setup that includes both a writer instance and a reader instance. This division is key. We have separate instances dedicated to writing and reading operations, and they are located in different availability zones, AWS. This is where the power of Aurora truly shines, providing resilience and high availability. When you click on Database 1, you'll notice that there are 2 types of endpoints available for connection, a reader endpoint and a writer endpoint. These endpoints are extremely useful as they point to the appropriate writer and reader instances, ensuring that your application connects to the correct resources. However, if you navigate directly to a specific instance here, you'll find that it also comes with its own dedicated endpoint. Please note that if you check an instance that is still in the creation phase, it may not yet have a dedicated endpoint available. Moving on, let's highlight some additional features that enhance our database functionality. For scalability, we can effortlessly add more readers to our reader cluster, which can help manage increased traffic and load. Moreover, if you're looking to expand your infrastructure, creating a cross-region read replica allows for data access in different geographic locations. One of the standout capabilities of Aurora is point-in-time recovery, enabling you to restore your database to any given moment within the backup retention period. Also noteworthy is the option for automatic scaling of replicas. This feature is vital as it allows us to set up a policy that automatically adjusts the number of replicas based on average utilization or the number of connections to your Aurora replicas. This ensures optimal performance while keeping resource usage efficient. Let's talk about configuring the read replica scaling policy. First, we want to ensure that our read replicas consistently maintain a target utilization of 60%. If we find our usage exceeds this threshold, we can set it to automatically generate additional read replicas. It's also wise to establish a scaling period within this policy to manage how quickly these changes take effect. Moreover, we should define both the minimum and maximum capacity for our read replicas. This allows us to maintain 1 replica as a baseline and scale up to a maximum of 15 Aurora replicas. The automatic scaling of read replicas is a crucial feature as it significantly enhances database performance and resource management. Now, we can set aside the scaling policy for the moment since it's not our immediate concern. We've ensured that both my primary database and its endpoints are fully operational, so we're all set there. One of the standout features of Amazon Aurora is its ability to expand across AWS regions. To illustrate this, I'll demonstrate how to add a new AWS region to our database. Please note that this functionality requires selecting an Aurora version that has the global database feature enabled. By integrating additional database regions, we unlock the capabilities of a global Aurora setup, which offers significant advantages for applications with a worldwide user base. However, it's important to point out that this particular cluster is not yet configured for that, as we need an instance type that meets the compatibility requirements. To proceed, we should upgrade our instance to a larger size, such as a large type, which will then allow us to incorporate other regions into our Aurora database cluster. Nonetheless, I wanted to make sure you are familiar with this powerful feature. In summary, Amazon Aurora delivers an impressive database solution with exceptional performance, robust scalability, and global deployment capabilities, complete with serverless options. It truly exemplifies a comprehensive database offering from AWS, optimizing both functionality and efficiency. As we wrap this hands-on session, if you wish to delete this database, you'll notice that it cannot be removed right away. The first step is to delete the read replica instance. Simply type in delete me to confirm the action. Following that, you'll need to delete the primary writer instance. Again, just select the action to delete and type delete me for confirmation. After both instances have been successfully removed, you'll then be able to delete the entire database cluster. I'll pause here and wait for that to complete. And there we go. My database has now been successfully deleted, and I look forward to seeing you in the next lecture.